The next transformations that we need to discuss are stretching and compressing. So stretching and compression. So suppose g of x equals a times f of x, where a is a real number greater than 1. This will stretch f vertically by a factor of a. So say a is 2. G of x equals 2 f of x. F is stretched vertically by a factor of 2. If a is between 0 and 1, then f is compressed vertically by a factor of a. So say a is 1/2, f is compressed vertically by a factor of 1/2. So it's 1/2 more squat, if you want. So this is just an example. I probably should have put dots at the end of this, but the example is just these two little line segments. It doesn't continue on. This is actually a function. I'm not pointing at something here. It kind of looks like that, but I'm not. This is the actual relation right here, the actual function, the graph of it. Okay, don't have an equation for it. It's just this graph. Now, if I take f and I multiply it by 2, then all of the y, I'm multiplying the y values by 2, but keeping the same x values. So when x is 1, for example, f was 1, now it's going to be 2 times 1. I'm sorry, f of x, y is 1. Now y is going to be 2 times 1, so it's up here at 2. So the height is just doubled on this orange one. See, so like this is also 1, so that's at 2. This is at height 2, so this one should be at height 4. And I just connected. They're line segments, so you can just connect the line segments, okay? So that's stretching by a factor of 2 vertically. And this is what happens if you take 1/2 of f of x. It compresses the function vertically by a half. So instead of the height of this point, when x is 1, instead of y being 1, it's now 1 times a half. So it's now 1/2. Same with this point. When x is 3, this has height 1. I'm sorry, this has height 2. So now we take half of that and you get height 1. So it's compressed this h multiplying by f by 1/2 compresses the graph by vertically by 1/2.